Hello, guys. I hope you guys are doing well. So, I'm your instructor, Adnan Munir, for the computer engineering courses. Okay. So, in this channel, actually, we will put the different lectures about the computer engineering, especially the computer architecture, the advanced machine learning courses, neural network courses. So, this is our first course, which is actually the introduction about the computer architecture. So I'm your instructor and I'm going to request please subscribe this channel, press the bell icon so that whenever I'm going to put my video, so that you guys can get the notification about it. Okay. So here in this lecture, actually, we are going to see the computer architecture and the assembly language. And it's these slides are taken from the King Fahd University professors Dr. Mudawar, and I'm going to give the credit to Dr. Mudawar about these slides. So in this lecture, actually, we will see like what is actually a hierarchy of the languages. Okay, the language, actually, we know the application programs, different programs like on the different apps on our systems. So it's all application programs, and then there are some programming languages. These are the high level languages. Okay, let's suppose we have the C language, we have Python, we have Java. These all languages are the high level languages. Okay, so there are connection between the high level language and the low level language. This area, this portion is the low level language. In low level language, we have the assembly language and the machine language. Okay, what is the machine language? Machine language is the zeros and one, the binary format, and it is easily understandable for the hardware. So machine language is very close to the hardware, then the assembly language is little bit closer to the hardware, but the high level language, there is no understanding of the hardware for the high level languages. So there are some procedure how the high level languages are gonna be understand for the hardware. Okay, so we will see in the next slides as well. So because this is the introduction chapter, so we will mostly focus on the introductions. Okay, so there is the assembly language and machine language. The machine language, as I told you before, it's about the one and the zeros, mostly the binary format. Okay, so it's native to processor, mostly the executed directly by the hardware. It's machine language. Our hardware can easily understand the zeros and the one formation. Okay, then it's come the assembly language. Okay, assembly language is little bit higher language than the machine language. Okay, so its readability of instruction is better, like as in assembly language you write like add a comma b, subtract, sub, different command, multiply, mul command, and there are different commands. So it's the readability of instruction is better than the machine language, because I told you in machine languages there are like the binary language, like 1 0. So its readability is not much better in like we have in assembly or the high level language. Okay, so it's like one to one corresponding with the machine language instruction. Okay, so mostly the assembler translate here we have to think about the assembler. We will see like what is the assembler. Okay, what are the linker, what is the compiler, we will see in the next slides. Mostly assembler translate the assembly language toward the machine level language. Okay, so the compiler, what are the compilers now here? The compilers are actually translating the high level language toward the low level language. So high level language from the assembly language, or from our high level language toward the machine level language. So this is the work for the compiler. Okay, compiler actually translate a high level program to the machine code. Okay, either directly as I told you, or via the assembler. Okay, so this is very good slide for your understanding. So what about the compiler and the assembler? Actually, we have the high level languages. Again, here we have C, we have C++, we have Java, we have Python. These are the high level languages. Okay, and the compiler can do the both. Okay, compiler can do the both option. Either way, it can directly convert the high level language toward the machine level language, or either way it can use the compiler for the assembly language, and then for assembly language toward the machine level language. Okay, So this is actually the compiler and assembler. Okay, I hope this is clear. Then there are like instruction and the machine language. Okay, what exactly the instructions are? Instructions are, like we tell the computer like what exactly we are going to do. So each command of a program is called as an instruction, like the add a comma b. This whole is instruction. Sub subtract a comma b is an instructions. Okay, so there are many instruction set we will see in our third chapter in instruction set. So there are like computers only deal with binary data. This again well known. Our computer systems, our systems are only deal with the zeros and the one formation, mean the machine language. Okay, so the set of all instruction in binary form make up the computer machine language. Again, machine language is composed with the binary format, ones and zero format. Okay, so this is also referred to as an instruction set. So these are also known as the instruction set as well. So we will see briefly in in chapter 3 what are the instructions and what are the instruction set for this architecture. Okay, so because every architecture have the different instruction set, like Intel have its own instruction set, and nowadays like Ryzen have their own. So it's like every system has their own instruction set. Okay, so then we have instructions. Then in instruction we have two field, like the opcode or the operand. Okay, so what is actually the opcode? Of course, let's suppose I'm gonna write like if I'm going to write like add, if I'm going to write like add, I'm sorry, it's like actually today. uh just let me erase this. Okay, and let me use my pen tool. Like let's suppose I'm going to write like add. There is, let's suppose, it's just for your understanding. Okay, there is one register A and I'm going to use a capital register and capital B. So there is no register, but I'm just for your information, I'm just telling you. Let's suppose we have this add command. This whole is known as the instruction. This whole is known as the instruction. Okay, so let's suppose add a comma b. Okay, here add is our opcode. Okay, add is our opcode, like field which stand for operation code, and it specifies the particular operation that is to be performed, like the add. Here it could be the subtract, here it could be the multiply, addition, whatever it is. Okay, and these two, these are our operands. These are our operands, like operand on which actually operation is going to be performed. Okay, so a and b are our operand, because add operation is going to perform on a and b. So what are A and B? Okay, we will see. The A and B, it could be the operands can be the constant. Constant mean here it could be the value. A could be the 1, 2, 3. B could be the any value. Okay, integer. Or A and B could be the registers. Okay, it could be the registers, like A, like we know, like there are some registers in our architecture. Okay, and these arb could be the memory addresses as well. Okay, so operands could be registers, it could be the immediate value, it could be the general purpose registers, or it could be the memory addresses. Okay, from that address we are going to load the value and we are just going to add. Okay, so I hope so. Opcode and operands are now clear. Again, opcode, this add is opcode, because when it's going toward the machine has its binary value. Let's suppose we say like machine has its binary value like 1100. Okay, 1100, let's suppose. It's not like obvious, but it could be like 1100. So add is our opcode, and a and b are our operands. Okay, and here what this small a is actually the destination. It could same, it could also be the registers, memory address, memory location. Okay, so this is our destination. A and b is our, let's suppose, our is our source, and this is our destination where actually we are going to store our value. Okay, I hope this is clear. Okay, this is the slide actually translating language. We will actually cover this in lecture 3, because at this time you guys are not familiar with the MIPS assembly language. So we will cover it in lecture 3 when we are going to read the MIPS. But it's actually like we have the high level language, then the compiler will, what compiler will do, compiler will convert into the assembly language. Okay, with compiler we are going to convert an assembly language, and then from assembly language, assembler is going to convert it toward the machine language. Okay, We know that the compiler can do the both. Compiler can directly convert from the high level language toward the machine language. But here in this slide, it's actually compiler is going to convert from the high level language toward the assembly language, and then assembler is going to convert from the assembly language toward the machine language. Okay. And again, a statement is a high level language is translated typically into a several machine level instructions. Okay. There are several instructions actually. So what are the advantages of high level languages? Again, the program developer is faster because as we are the developer, we are the coder programmer. So it's very easy to write any function for us. Okay, readability is very good. We can very easily we can code, okay, for the high level language. And the program maintenance is easier. We can easily debug where the error is, so we can easily maintain our code. Okay. And definitely for these things, the for a low level language, this is not for the advantage for the low level language, because for low level language you particularly you must know the concept of behind the instruction and what exactly is going to be do by this instruction. You must have to know. However, assembly language programs are not portable. Again, assembly language program are not portable. Each program, assembly program is for a specific architecture. Okay. So why learn assembly language? Okay, so there are many reasons. Okay, again, accessibility to the system hardware. It's very near to the system hardware, so you can access the hardware by this assembly language. Okay, the time efficiency, because it's very near to the hardware, to the machine language, so it's time efficiency is good. Okay, the space actually, why space? Because we know which register we are going to use. Okay, which memory location. So that in that case, space is also like. Is a good factor in assembly language. Okay, again, accessibility to system hardware. Again, assembly language useful for implementing system software. Okay, also used for small embedded system application, like we have different architecture, like 8051, we have 8051, we have PIC microcontroller. So these microcontrollers are actually based on the assembly language, so you can easily code these embedded systems. Okay. And then again, the same thing, space and time efficiency, source program inefficiency, tuning program performance, writing compact code. So this is the actually benefits of the assembly language, learning assembly language. Okay. And again, in assembly language, we have editor, we have assembler, we have linker, we have debugger. Being a programmer, we know the editor. Editor is that thing like in which we are going to write our code. Okay, like for the MIPS, we have Proton. Okay, for high level languages, for you can see like for the C and C plus, the previous that was the Dev. Okay, for C sharp, we have the different tools. Okay, these are the editors actually for idle, for the Python. So these are the known as the editor. Okay. And what is the assembler actually? Okay, assembler, again, the thing is which are gonna be convert for the high level language toward the machine language. Okay, sorry, for the assembly language toward the machine language. Okay, this is your assembler. Okay, and it's programmed into an object file. It's create an object file. Okay. It's very important like to see what assembler do. Okay, so object file contain the machine instruction. What is the object file? Object files are nothing, just they have the instruction for like a machine language instructions. What is the linker? The combines object file created by the assembler with the link libraries. Okay, when we are going to use our system, definitely we have to access the RAM, we have to access the ROM, we have to access the hard disk, we have to go to access the cache memory. So for all these, there is the linker which is actually gonna be link our object file with these libraries. Okay, so it always produces a single executable program like that exe file. Okay. And debugger, again, for the debugger, we can easily debug the error in our code. Okay, we can trace the way actually where our code stuck, actually which memory location we are going to access. So with debugging, we can access the memory location, we can access the register value, we can check the whole instruction. Okay, so this is the work for the debugger. And this is like assembler and link processor. Okay, so if we have different source files, so we can by assembler can create the different object file, and these all different object file with the linker, it can create a one executable file. Okay, so again, a project may consist of multiple source file. Okay, it's not necessarily like there is one file. No, so it could be a multiple source files. Okay, so linker links all object file together with link libraries. Okay, so this is like a mars. Okay, for the assembly, MIPS assembly we are going to use in from our third lecture. Okay, then okay, the components of a computer system, inshallah, in our next lecture we are going to we are gonna study the component of a computer system that is very much important, like ram, rom, the processor. So we will see in our next lecture. Okay, for till this lecture, please study this lecture, just see this lecture, and please tell me in the comment if there are some gaps in it. Please, again, I'm going to request subscribe my channel. I will make a good videos for you. Okay, so I'm also going to post different actually subjects like the machine learning subjects. So I hope you guys enjoy this video. So we will see you in the next video with the component of a computer system. Thank you very much.